hey, we can delay the drug and we can do more testing. It's going to cost us $50 million, or we can let it go through, because if anything bad happens, we'll do a $10 million insurance payout. We're still up $40 million. What did I stop? I think I stopped on drift detection. All right, so basically, where I'm at is I am actually building out this platform for coaches who want to actually do assessments, right? So normally what assess when you do assessments, they're basically like questions, like they'll give you like 30 questions, and then you can actually get like an assessment, right? Like the Myers-Briggs. What kind of leader are you? And these are boring, right? So I'm working with a coach right now, who's been in the business for 25 years. And I said to her, hey, you know what? We should do scenario based questions. It should be AI driven. I'm not going to get all detail on this in this live, because this is not what this is about. This is just me working through one of the pillars of the development. What I will say is that the way that I work, my life cycle works, my AI development life cycle works, is that I spend about 10 hours before anything is developed looking at architectural decision records, and they form the pillar of whatever I'm going to build. So as you can see, I have like about 18 pillars and a canon document that I'm going through. And what it means is that I took all my conversations, everything, my thoughts, I dump it in, and I have a special prompt that I use, which is this prompt right here. And it actually then goes through all my transcripts, all my ideas, and it's going to create ADRs for me, right? Architectural design decision records. And the thing here is that after I do these, I go through them painstakingly. I go back and forth. I speak to the AI, because this is going to form really the basis of um it's going to form the basis of whatever I'm developing, right? So I do not shortcut this. 10 hours, I know 10 hours is a long time, but I go into everything, right? So one of the things that I do have is I have two things. I have an AI production framework, which I spent about a year writing. It's from tons of engagements that I've had in AI, developing like enterprise, high security, right? Sort of like applications with AI. And so over time, I kind of like just wrote this Bible, so to speak. And then in addition to that, I actually have a field guide, which I'm about to release and make open source. But it's a very, very deep field guide on how to release AI agents, right? That scale. So basically, those form my basis, and then I take the transcripts and I take the conversations with the company, in this case the coach, and just me walking, talking in my car, right? Just kind of design this thing, and I kind of dump it into my into Claude Code, and then I run the prompt which I just showed you, and what it does, it then creates this evidence of understanding, and what it has to do is that it's proving to me that the AI understands what I'm trying to build and how it understands what I'm trying to build against my production framework, against my field notes, right? And then because I don't trust it, it actually does an evidence of understanding. And the evidence of understanding is what it understands it is going to design for me. And then what I do, and this is what takes around 10 hours, I will painstakingly go through each one of these, and I will talk to the AI and we'll have a conversation. I will clarify things, I'll ask questions, I'll give it feedback. And this is the process that I'm doing on the live here today. I'm doing a very interesting pillar. As you can see, I have multiple pillars. I have done all of these already. All right. So I'm on the reliability pillar right now. Let me see. Did I skip privacy? No, yeah, I skipped privacy. I know I didn't skip privacy. I did privacy. So I'm actually on reliability right now. And then for my reliability pillar in my AI production framework slash Bible, I have 14 principles. And what this does is that it takes each one of the principles, it repeats it so that AI can prove that it actually read it. And then it lays out a conversion between the principles and what it means for the project that I'm working on. And what I do is I read this to make sure that it understands the principles. Then I read this that it's going to apply the principles correctly. Now, after I do that, after I do all this process, I then work with the AI to convert this into a PRD, into specification files, into stories, and then actually I start developing. So 10 hours, this is the most human time I will spend on this project. Everything after this is going to go pretty quick, to the point where I get to the ending where I use a DAG, right? A graph. And I actually have all my stories, and I can just basically tell my AI, I just tell my AI, hey, go ahead and develop this for me, and I walk away. Like I'll have my test plan in there and everything, and I'll just go away. And this will be code for like around 12, 15, 16 hours because what I'm building is like really serious. I'm building like this AI I'm building this AI agent that has to stand the rigor of being able to be used for assessment for C-level executives, be able to be private, secured, reliable, have governance, have transparency, have fairness in there. Look at economic architectures who can actually scale without actually making my coach go broke. Operational sovereignty, so that we don't have to rely on one individual, sort of like frontier lab. All these things is in there, like feedback loops, everything is in here, as well as an API that two APIs that give one API that gives access to the model and another API that's a control plane that you can actually manage the model. It's a lot, right? So where I am right now is I'm looking at the reliability piece, right? I'm looking at the reliability piece. And what I have in the reliability piece is that I've gone through how do I handle evaluation? How do I handle golden sets? I've already looked at how can I handle output quality monitoring in production. And I think I just did the yep, and I just did drift detection. No, I'm just gonna recap drift detection because that was the one that really made me go on live. Because like, man, this is so interesting. I gotta share this. So drift detection is how do I detect that my AI hasn't drifted over time. And what that actually means is that, hey, I'm going to be using Bedrock, AWS Bedrock. So what I want to know is, does the models underneath AWS Bedrock drift without me knowing, right? So for those of us who might not be doing production AI, you might not fully appreciate that over time there's subtle changes that can be made in models. Whether you are purposefully changing the models or the prompts, but sometimes the models can drift underneath, right? And you might not know. And when that happens, the responses that you get from the LLM, even if they were good on day one, they might not be good on day 120. So how do you ensure that that drift doesn't bite you in the butt? So that's what this is. It's called drift detection. And what I'm building is into the system is how are we going to handle drift detection, right? So in here, it looks like, hey, we're looking at weekly rerun of the evals, right? Against AWS Bedrock. And how that works is that I'm going to take a golden set. A golden set is basically going to be some questions, right, that I take from the eval. And then because the eval is an AI that takes the questions, converts it into scenarios, and then based on the person's answer, it kind of checks off the box after what are the questions have been asked. So I have to ensure that if the same scenarios get actually produced against a same model, then the same answers would suffice. That's really what a golden set is. And drift, sort of like detection, is you can run this automatically behind the scenes against the model over and over and see if it's somewhat deterministic, right? So that's what I'm doing here. So that's drift detection. I just did that piece. So the next piece I'm going to look at is the structurally validated. So in plain English, my principle says never trust the model's output shape. Check every envelope before it goes downstream. So in this particular project, what it means is that every classification must match a schema, right? So never into the state engine. So I'll be like, I'm going to just go in here and I'm going to say, okay, cool. All right, I'm ready to look at P5 underneath the reliability pillar. Can you expound on that a little bit in terms of our use case? I know, for example, the classification, I believe, is actually explain to me again what we meant by how we define classification here. I do understand what we meant by schema, right? We are looking at the declarative manifest, right? And I believe that's what you're talking about. So every classification against the declarative manifest, never in the state engine. I do not understand what you're saying here, right? And I'm worried that you're kind of like conflating some of the principles. So let's just spell this out a little bit so we can go back and forth and ensure that we're doing the right thing. All right, as you can see, I use Whisper, so I really don't even type anymore. But yeah, so at that point, what we're looking at is, let's see what the breakdown is. Yes, I think very clearly that the golden data source has to come from the actual application, but it's not going to be from the user facing application. I think it comes from the admin that utilizes the coach in plain API to actually do that. So um, yeah, I think that's where the golden set gets seeded. The golden set has to get seeded by the coach. It doesn't get seeded by the actual use. That comes later down in the pipeline. Um, yeah. So based on that, do you and previous conversations, do you believe that you have the answers to the questions 1 to 3? All right. So again, the idea here is that remember we're dealing with reliability of the AI, right? So one of the biggest things for the reliability of the AI does is the information and the data coming back from the AI structurally validated, right? So basically, what's happening here is that what this checks is whether whenever the AI model returns a value, does it match the schema that we have? So I'll explain what that is, right? So if I have a bunch of questions and each question has a rubric as to what validates or verifies that the question has been answered, right? It means that when the AI comes back with its responses, it has to have a particular shape, a schema that says I can now validate it or check it against the rubric. Now, you cannot expect, or it's bad shape and it's bad form, bad practice to just say to the AI, hey, just be sure that you return the data in this shape. You can't do that. It will work 99% of the time, and 1% of the time it will fail. So what this actual principle says is that within the actual deterministic portion of the application in the harness, we need something that checks that the schema that comes back from the AI model is consistent with what we expect. That's all this is, right? And it also extends on to here, says that we also have golden set data, and golden set data is basically test data. So the way that golden set data works is that I can take a bunch of questions and answers, and I'm simplifying it, and I can run it over and over again because I know what the output is supposed to be, and that's how I test the AI. That golden set, right, in terms of the information that goes into the golden set, which is the inputs and the outputs and the context, it itself has a schema. So basically, all I'm saying is that I don't want the AI, I don't want to depend on the AI solely to actually ensure that the schema rules are followed. I need to also have some sort of deterministic code and some sort of check-in that is sort of like a police for the LLM. That's all that basically says. So all I said here is when I looked at the questions that the AI review kind of brought up to me, I just basically says, "Yep, we're gonna adopt what you actually recommended, and we're good to go ahead." Right. So then once I do this, I say, "Hey, I'm done with P P6. I'm sorry, P5, and I'm going to go to deterministic orchestration." Right. So basically, this is one of the biggest parts of this application, and I'll explain what this means. So orchestration has to do with how the AI goes about doing its job. In this case, I am doing what's called a model bounded, right? A model bounded AI agent with just a little bit of a touch of a utility agent. What it means is that in this case, because we're asking questions, right, to let's say a CEO or CFO to perform an evaluation, we know that there's certain things that we have to ask. We're going to present those questions as scenarios. From the answers from the scenario, the AI is going to reason itself back to the question. And it's going to basically check the question off. The question will have a rubric. And will check little pieces off of that rubric until it checks everything off and it says, oh, question has been answered. So it's not about just a binary, has the question been answered? Or no, you cannot do that with an LLM. You have to be a little bit more nuanced, right? A little bit, take it pieces at a time so that the pieces that you can say yes or no to, and when everything is a yes, it means that the bigger body says, yes, I am done. So basically what this says is that to be able to do that, I'm going to be having a conversation with the user, with the user back and forth. That requires orchestration. The orchestration here is, okay, if I need to find out this particular answer to this question, right? What is the best scenario I can come up with? And then as I have conversations, what are the new scenarios I can actually come up with? That is orchestration in this case. So what this is asking and this is saying is that, hey, within reliability, you can allow the model to think. So it's going to reason itself to say, this is a scenario I need to generate because I need to find out the answer to this question. But the flow in itself must never be boring, right? So the turn loop is fixed, right? So it's going to be it's a fixed loop. It's classify, validate, transition, target, and then offer, which is a fancy way of saying I'm going to classify what I need, then I'm going to validate that's what I truly need. Then I'm going to actually do a transition in my state from one thing to another. Then I'm going to make a targeted question, and then I'm going to actually offer and write out what that question is. So in this case, the LLM never decides what happens next in the pipeline. So this is actually interesting. I'm going to make a clarifying statement here to the AI, so I make sure that it is not going to hallucinate an answer, because this is such an important load-bearing pillar of what I'm building. So you'll see what I'm about to do. So here, what I'm going to do is I'm just going to clarify something. Hey, I just want to make sure I'm clarifying on P6, which is a deterministic orchestration, that we are not fencing too tightly, right? Remember, part of the power of the AI model here is reasoning to understand what is the current state, right? From our declarative manifest, if you remember that, right? So we have to make sure that we give the AI enough space to reason itself, to ask the next scenario. And if you remember, we're doing like a poor man's version of Markov decision protocol, right? Or the Markov decision process, where we're actually not using the probabilistic transitions right now, but we are doing a first level. And the idea is that we'll do the full probabilistic transitions later on. I want to make sure that your interpretation here does not affect that, right? Because you're saying that the flow must not be boring. The model may think, and I think you're saying the same thing that I'm saying, but I just want to make sure I'm confirming that that's still the truth and you are not changing that. Yeah, so as you can, Tiffany, as you can see, there's a lot that actually goes into creating this sort of like production vision systems. Like anyone can basically say, oh, I'm going to create a chat, or I'm going to create an assessment application that I'm going to do my assessments using AI. And what most people will do is just say, here's my questions. I'm going to load it up into an AI model and ask me questions. You can't do that. That cannot happen. Like if you're developing this to put in front C-level people and business leaders in Fortune 500s and Fortune 1000 companies, there's certain things that you have to do. And one of them is going to be the ability to create scenarios that is applicable or contextualized to what their situation is. So you cannot ask them about something that will be contextualized to someone that's a manager level in manufacturing, where they're a CEO or they're C-level in text in IT. It just doesn't make sense. They will sniff through that, and you will lose credibility. So what this does is allows the AI the freedom to come up with the answers to those questions, right? Without being boring. Now, the other thing, if I talked about Markov decision, sort of like protocol, some people call the Markov decision process, right? And that's usually the name for it, Markov decision process. What it does, though, is it fixes a key problem with goal-based AI. So goal-based AI, if I say to it, generate me scenarios that will answer this underlying 24 questions, it is going to be very greedy. And it's going to create scenarios that try to answer all the questions at once. But if you do that, and you know what I'm going to say, if I try to do everything at once, then I end up doing nothing at all, which means I create scenarios that are kind of like implausible. That doesn't make sense. The scenarios are too long. They're trying to extract too much information. So what you want to do is scope the work, right? That's a very important AI discipline too, right? You want to scope work, right? So if I scope it, I if I tell AI to do it by itself, it's going to scope it to be greedy. So I have to figure out a way how to scope it not to be greedy, but at the same time not to be inefficient and not to be boring. Because you do not want to scope it in a way where you have to ask somebody 60 questions or 60 scenarios to get the answers to an underlying 24 questions. So what is the good middle ground? That's where Markov decision process comes in. And it's a very interesting topic. I'm actually going to do a long form on it, but basically it allows us to actually introduce utility calculations to basically understand, okay, what am I going to give up to get something else? So it can actually find the middle ground. And over time, once you gather enough information, you can then start using transition probabilities to say, okay, if I'm in this state and I want to move to this state, what is the highest probability safe thing I can do? And in this case, what that interprets to is, what is the perfect scenario I can create so I can get the most answers as possible against my underlying question state, but at the same time not to be boring or repetitive. It's a really interesting process. So that's what we're kind of doing here. Yes, it is the Markov. Yeah, Markov. Yeah, so I actually use the Markov decision process quite a bit. I actually am working on a really big project where I'm building a relationship development rep. So not an AI rep. So most people build AI development reps to sell. I'm building a relationship development rep to sell, where it will develop a relationship with someone by giving them tools and tips and checking up on them. Now, if I let a goal-based agent do this, a goal-based agent will try to rush the relationship, right? So that the relationship can actually mature into a sale. But with Markov, Markov allows me to make these calculations that say, okay, if I am on this, if I'm in this phase in the relationship, right? And I want to get the relationship to a point where it's like you have so much trust in me, I can sell to you, right? Markov basically says, at this point in the relationship, I have these probabilities of ending up where I want to go. Show me what is the next step so I can land where the probability towards the end is great, where I don't lose too much of where I am right now. I mean, it's basically saying like maximize for safety of not ruining the relationship, but at the same time, within that, maximize giving me a greater opportunity to get to the end game. It's a really interesting concept, and I will do like a whole video on top of it. But here's what the takeaway is: there are two types of agents that are very, very close to each other. One is the goal-based agent, and a goal-based agent, you tell it what future state is supposed to be. It understands existing state. Yep, you're talking MD. You know the deal. It's MDP. Yeah, you hit it. MDP, right? I love MDP, and I don't think enough people talk about MDP in agents, right? Because agents, a lot of agents are goal based, right? And in a goal based agent, it's always tries to be greedy. And if you introduce MDP, right, you basically say, I can take a goal based agent and then introduce utility calculations and say, what is the best way to get to my outcome without jeopardizing where I'm at? So that's basically it, right? Yeah, Tiffany, you get it. Sounds like you've actually looked at MDP before, right? Or used it in different places. Yeah, exactly. No, that's the so here's one of the really interesting things about AI, right? Is that I spend 60% of my day digging up and introducing into my AI old concepts, concepts that we've already done and we tested, and a lot of people do not look at. I've been resurrecting them and dropping them into AI because they just work. Like, for example, things around Bayesian probabilities, MDP, good old fashioned reliability engineering. It's interesting that all of those things actually have a place in AI. I'm glad I have your will. I'm glad I have your will spinning. That's exactly what I want to do. And so that's my thing. My thing is that AI production, AI is not really about AI. It's about everything around AI that makes AI work, right? And again, you know about MDP, you can see where MDP is just this awesome concept that you can use to make a greedy agent not so greedy. Because that's in the news when you hear about agents going wild, it's all because they're goal based and they optimize for getting their goal done. MDP changes that behavior where it optimizes not for the goal, but it optimizes to get to a next state that gets it closer to the goal while not ruining stuff. I like to put MDP like that. All right, so let's see what came back. So it says here you're saying the same thing, and nothing about the MDP design is touched. It says it works, and basically it says like, okay, cool. We're on the same page, and I'm just gonna be like, okay, I'm gonna ask. So are all the questions you have for me for P? Actually, no, the questions are not done yet. I gotta go on to the next one. So next thing I'm gonna look at is latency is reliability. Slow is kind of broken. Yes. Yes. Slow is kind of broken. So let's have a conversation about this, right? So one of the interesting things in AI, right, is this idea of I want to make sure I use the right term. Actually, we are just talking about it a second ago. So I want to bring it up so I can actually show the screen because I don't want to do it disservice. Because the AI explained it so properly the last time I talked about it. I will, yeah, there you go. The idea of SLOs, right, versus SLIs and SLAs. So most of us, if we're working in enterprise, mid-sized companies, you know what an SLA is, right? It's a promise in a contract with a customer, right? Say, I'm going to do this. But here's the thing, SLAs are built on SLOs and SLIs, and most people just don't talk about it. In other words, I cannot promise you something unless if I know what I'm promising you. So that's your SLI. The SLI is the service level indicator that says, hey, here's what I'm going to track, right? And then the SLO says, I'm going to track this, and this is the metrics I'm going to keep. I'm going to keep them within this bounds. And then the SLA says, I am promising to keep this in these bounds, or else something bad is going to happen to me. You're not going to pay me, or I'm going to have to give you a discount, or whatever it is. A lot of people I meet do not talk about when you create AI agents. One of the first things that you need to do is write the SLA, right? You need to write the SLA, you need to write the SLO, you need to write the SLI. In short, tell me what matters for this AI agent. Tell me what I'm about to measure to make sure that the thing that matters stays within bounds, and tell me what I need to do if it falls out of bounds. SLA, tell me what to do if it falls out of bounds. SLO, tell me what the bounds are. SLI, tell me what is important to actually track. Yes, yes. Go back to some of the foundational things. The foundational things make a whole difference, man. Like, trust me, Tiffany. If you go back to some of the foundational things, it is crazy. Yeah. So if you go ahead and so basically what this is forcing me here to do at P9 is that P9 is introducing latency as reliability. So if I'm looking at the SLI, the service level indicator, right off the bat from the conversations that I had with the coach that I'm working with, we know that if someone is sitting in a room and they're taking the assessment, right? We cannot wait for 5 seconds for the AI to come back on every turn. That's going to be annoying. It has to be this quick conversation, right? Like you're talking, they may be talking or they're typing, it's going back and forth, and they feel like they just with our coach, right? They're with our coach, they're working together. It's like, man, this is smooth, this is nice. So right off the bat, I know one of the SLIs is going to be speed. And when you talk AI, one of the things you want to say is don't say speed. Say, especially when you're talking streaming tokens or streaming AI, right? Like when you're chatting, right? It's about streaming information back and forth. So what you want to talk about is time to first token, right? So every time I'm talking to you, the AI is going to bring back and stream me back tokens, stream me back information, right? The strings, the tokens, and the person wants to see that showing up on their screen, even if it's not all of it. It could be all of it, or it could just be writing line by line as the tokens come back. So it's not about can I get you the whole answer back as soon as possible, is what is the shortest amount of time does the user, on the other hand, is having this conversation with this coach for this assessment, start seeing answers or the return turn of that conversation that they're having. It's called time to first token. So in here, you'll see part of the reliability thing is, hey, latency. If you're too slow and there's latency, then that becomes a reliability problem. And slow is kind of broken. And you can see here it says that less than 1.5 seconds on the first token is my contract, streaming always, per stage latency budgets. Now, what it means by per stage latency budgets is actually pretty simple. If I have an SLI, right? And let's say the SLI says that something needs to be up 99%. Like I'm doing uptime, 99%. It means that the SLO, which is the service level objective, has to be we keep this up 99% or more. It means that 1% is where we can fail. 1% is our budget, right? So if there's 100 hours, it says out of the 100 hours, only for 1 hour can it be done. So that's your budget that you get to spend. And as soon as that budget drops to zero, someone must know that it's happening. Or if that budget is getting closer to zero or to crossing the threshold, someone needs to know or something needs to be done. That's what that means. So when it says here is that the per stage latency budgets that's what it means. It says so it's less than 1.5 seconds. First token is contract, streaming always, and then you're gonna have a per stage latency budget, right? So I'm gonna ask it, what do you mean by per stage? Because I know what a latency budget is, but what does it mean if it wants to do a per stage latency budget? What do you mean on P9 that you're looking at a per stage latency budget? Can you kind of lay that out, especially with the examples you gave of target, offer, and classify? And I think as soon as I read that, I know exactly what you're talking about. You're talking that the stages of this is target something, offer it, and then classify it. But again, still clarify what that means. I do understand what you mean by streaming always, and I do understand the less than 1.5 second first token is contract. I absolutely love that. But after you answer this first question, this actually brings up a very important point about SLI, SLOs, and SLAs. I think we need to have a definitive conversation and a detailed conversation of what all the SLIs are for this actual application, with time to first token being the main one, but I believe there's maybe some secondary and tertiary ones as well. All right, so then this is kind of what gets important, right, team? Because at the end of the day, look at what the AI is doing here for me, right? And this is why you do not want to skip the ADR phase, the planning phase, because the AI looked at this and it says, "Hey, I know time to first token is important," because it looked at what we're building and it's smart enough to know that. But guess what? It doesn't understand that that cannot be the only SLI. So I saw that because I'm doing the review as the human. I have knowledge in the space. So I'm going to push it and say, you need to find me more SLIs. Let's have a conversation about the other SLIs that we actually can use. And not only do we do that, I also understand that the SLA and the SLOs at this time need to be created. So I'm going to force it to create all the SLIs, all the full SLOs, and then the encompassing, right, SLA. So I'll have that in the project as a project definition. So it means that when I start creating stories for this application, it's always going to be a guardrail. We're always going to start evaluating everything we build for this application against those SLIs. All right, so it kind of came back. See that nice long explanation. It says the per stage latency budgets. And you see, it says there's a small correction. The stages are classified, target, offer is the stage that writes the next reply. Offer is the stage that writes the next reply. So basically, it says that the user experience is one number. The person speaks, an utterance is sent, a first token comes back in less than 1.5 seconds. But that total is spent by a sequence of stages at its turn. So the budget must be decomposed. Otherwise, if it has determined that something takes 3 seconds and we say it's slow, we don't know why it's slow. So basically, all it's saying is that, look, every time a turn happens in the conversation, someone is using the app, they speak. It goes out to the AI. It first needs the utterance. It first needs to be classified. Hey, what is the utterance saying? Right? Classified against the declarative manifest, which is just a fancy way of saying against the underlying 24 questions and their rubric. Right? So it has to be classified. Then it has to be targeted. Then it has to be offered, which means written. It's saying that for that whole chain, it needs 1.5 seconds. Now that's ambitious, right? But I'm going to keep it ambitious, right? But basically what it says is that you now need to break down that 1.5 seconds into the stages, so that when you start evaluating, or you start troubleshooting in the long run, when it's taking more than 1.5 seconds, you can come back and say, oh, it's because it's taking too long for the model to come back. Or it might be that it's taking too long for the model to classify. And let's say, for example, it's taking too long for the model to classify. You might then realize that, oh, we are using a foundational model that has reasoning on. And if its reasoning is on, it's going to take too long. Maybe we need to switch it to a small language model that has lower reasoning, because it might not take that much reasoning to classify. As a matter of fact, Anthropic, I just read the documentation 2 days about this. Anthropic tells you if you're doing classification, you can actually turn high reasoning off because it does not need it. So it's those kind of things you're seeing the insight on, right? So that I'm actually going to say this to this right now. I'm going to say this. I said, thanks for bringing this up. As a matter of fact, remembering the Anthropic direction, Anthropic advises, for example, to turn off reasoning or turn off high reasoning for things like classification. So here's what I want to do. I want to explicitly document somewhere in one of our ADRs that we do need to take a deeper look into the documentation of every one of the foundational models that we're going to use to ensure that we are following their guidance in terms of what reasoning and thinking looks like for each one of the stages in our workflow. So, for example, classify might require a different model and a different configuration on the API call. Offer might be something else, might be a smaller model with a different reasoning level, because we know that's different, right? So let's make sure that we have this somewhere, that this needs to be set in the system. And if that's the case, we also need the control plane API, which is the management API, to allow someone to change this from the admin portal, where they can actually go in and configure which model needs to be used. Now, I do understand that if we're using AWS Bedrock, that in AWS Bedrock, there is some work behind the scenes to make sure that all the models are available, because we won't be able to use and view models that have not been cleared, right, in AWS Bedrock. But nonetheless, right, we should be able to see all the models that have been granted permission in that account. That's what we should be able to see. Does that make sense? Right? And AI came back and said this makes total sense. AI said this makes total sense. It says, let's see what we got. And it's a beautiful case of your own doctrine agreeing with the vendors. And Anthropic's guidance says that no extended thinking for classification types task, spend reasoning only where it earns, and it is literally part of my production framework and Bible in my Pillar 13, right? That basically says reason is a resource, the harness allocates it, the brain consumes it. So we're going to lock it in as part of our stage model matrix, and it's going to attach free rules to it, and that's good. And it puts it into my canon document, right, which is going to mean that my AI won't forget about it when we start breaking down the stories. And I'm going to basically say like, hey, okay, and now I'm going to wrap this up on the SLI front, and I'm going to ask, hey, we just looked at the SLI catalog, and you create a definitive draft, I believe with 19 different service level indicators. Is that also logged somewhere for later on? And look, chat, I cannot explain how important it is um, to stop typing, right? Like, let me tell you, man. Like, um, and I'm not gonna credit myself for saying this. I have a mentee that I work with every single day, and he brought up a very, very interesting point. He said typing introduces mechanical fatigue, and mechanical fatigue is the direct enemy of how you work with AI, right? Because AI now is the place with a huge context windows that we have, right? And the way that it actually works right now, that having more information and conversations is going to give you a better outcome. The problem is that I don't know, I've ever met anyone who likes to type, present um, company included. So if I have to type, the thoroughness in which I'm attacking this could not be done, right? But because I can just speak and I love speaking, I can just wax. I can just talk, right? And I can have the conversations. I can remember things from the top of my head. I can remember things that are deep down. When I talk, it triggers synapses, that triggers memories. And I go, oh, I did this in this project, right? Oh, what about this? Oh, I remember reading this. And it just becomes a natural conversation. And this is where the AI shines, because the AI is made to do this. It's going to extract everything I'm saying, and it's going to apply it to what we're working on, right? So again, if you're not using a voice sort of like medium for working with I am going to tell you that you're missing out on not 10, not 20, not 30, not 40% of capability. You're missing out on 70% of capability. Your development will go next level once you start talking and get over typing. I don't type anymore, right? No, a little bit of hyperbole, I type, right? Because you don't use that, you don't want to use that function, but you get what I'm saying. You want to speak as much as possible. All right. All right. So now this is looking good. I am good with latency, is reliability, and we're winding down. Like I'm most likely going to end this live like around 3:15. And my goal was to get done with reliability, because reliability is such a fun one to work on. Again, that's why I came live. I was in the middle of doing it. And I was like, this should be alive, right? And I just kind of jumped in, no planning whatsoever. But I love doing lives because it's just me working. It's the most real that you'll see me, right? Like everything else, shorts, long form, like it's so rehearsed, right? If you really want to learn about, production AI, and I can teach you production AI, join my lives. Like, because you'll see me working in action. You'll see me looking at discipline, production discipline. You'll see me looking at my frameworks, my Bibles, past examples. And I don't claim to know everything. But what I do a very, very good job is every time I take in new information from projects that I work in, I put them into my Bible. I put them into my field guide. And my field guide and my Bible is always available in every project that I work on. And I do this with every project that I work on. So every project that I work on, I get better and better and better. And if you join my lives, you will get better and better and better, right? Because it's just about it's repetition. Like with everything else, it's just repetition, right? So basically, let's go to P10. So adversarial robustness. I love that word adversarial. It means that something is going to attack your AI, right? Or attack what you're doing. Robustness, meaning that can it work against adversarial forces? So things are going to test it. Situations are going to test it. For a reliability standpoint, what are we doing to ensure that when it hits those adversarial conditions, that your AI is going to operate within the acceptable bounds as defined by the SLA, right? So that's all that means. So you're going to test it, and basically what it means is that in plain English, test against people trying to break it, not just people using it nicely. So we say, how do we do this in this application? The AI is recommending that the eval set includes injection attempts, gibberish, and users fishing for the 24 locked questions, and you have to rerun it on every model change. This is so important. Like this is awesome. Like, again, I didn't write this. Like, I'm not taking credit for this, right? The AI going through, as I said, the transcripts and everything I gave it, and my production life cycle, and my production framework Bible, my field agent guide. Which, by the way, my field agent guide. If you want access to it, just comment in the chat, or comment if you're looking at this after. Leave a comment. I actually have this written. I actually mean to actually open source it. It is a series of actually sort of like research type papers. The first one is about 50 pages, and it lays out the 5 types of agents, how they work. It lays out the primitives for any agentic system: ears, hands, brain, context, memory, harness. And there's a seventh form, which is not really a primitive, but it's the fabric, it's the operating fabric. And then it describes how an AI agent works within all of that to be this fully durable, dependable thing. And then it actually extends that into the 5 agent types, right? Whether it's going to be reflex agents, or model-based reflex agents, or goal-based agents, or utility agents, right? Or learning agents. It talks about how those 6 primitives, along with the operating fabric, works to produce those different types of agents. And then I have some auxiliary papers on them too as well. So for example, each one of the agent types has its own paper. So for example, the model based agent has a 40-page paper. And as a matter of fact, this application that I'm building here right now is a model based agent with a touch of utility. And that's where the Markov decision process comes in, gives it a little bit of utility so that the model agent can have a little bit of discretion in terms of how it actually generates scenario. So again, all these things sound very academic. And one of the things I love about AI is that I believe from my experience, because I've been doing digital transformation for like 20 years now, it is the most exciting technology for me because it is the one technology that actually does not have a huge gap between academics and actually doing. Like I can sit here and I can write a 50-page paper on how do you build a goal-based agent with context and memory and curated context paths, right? And write paths back to memory and subjective and fact-based store. I can write that paper, and I can take that very same paper, I can stick it in my AI here, like I have, and I can build an actual platform on that paper. Excited, right? So if you're someone who likes to think about what you do, right, and think about possibilities and research and try out different research methodologies, AI engineering is for you. AI strategy is for you because the gap between strategy and R&D and actually implementation has never been smaller. Because you can have an idea, you can stick it in here, you can deploy something around and have it in production testing in a week and go like, yep, my theory works. Oh, my theory was crap, right? So just love it. Yeah, Tiffany, like if you're typing, like I can't help you. If you're typing, I can't help you. Like you shouldn't be typing. It's 2026. You shouldn't be typing, right? You should be using speech, and I use Whisper. So I don't make any money off this. I'm not big time yet enough to make money off affiliates, right? I'm just telling you what I use, and it works really well for me. I use Whisper. I use Whisper Flow. I actually have some of my local AI that actually does Whisper because I have my own Whisper deployment. I don't use it as much yet because I'm still kind of training it up a little bit more. But Whisper Flow works really well. That's what I'm using right now on the call, on this live. So basically, we're here, and I just said to it. So I said that we were like in the adversarial robustness. I love this. I love what it wrote here. It says eval set test includes injection attempts, gibberish. Like this is perfect. P10 is perfect, is exactly what I was looking for. So much so that I'm hoping that we did memorialize this somewhere in our ADRs in 18, synthesis and ADR backlog, because this definitively has to be done. I also know that we had conversations before on what the schema looks like for the goal set, right? So I want to make sure that if you see this being applied, that we do have this documented, that the goal set includes positive, negative, injection attempts, gibberish, phishing, and all that kind of stuff. All right, and as the AI kind of talks, I will say this. One of the reasons why this is important for adversarial robustness is, imagine if a user is kind of using the app to do an assessment, right? They're given scenarios, and let's just say for some reason an adverse user grabs the application. In this case, an adverse user would be classified as someone who wants to steal my coach's intellectual property. They want to find out what is the 24 questions, right? That is underneath, my coach's strategy and underneath their magic, right? Because I'll tell you, the coach I'm working with, she is awesome, right? Like she is magic, right? And what comes out of her brain in terms of her 24 questions, that's her IP. We don't want anybody having their hands on that. So you have to build the system out in a way that I can say to her, hey, I am 100% sure, right? Or at least as close as you can get to that someone is not going to figure out what your underlying 24 questions are, because I don't want them to know that, right? Also, you don't want somebody to game the system, because somebody can game the system. Remember, some of these assessments might be used for different purposes. You don't want somebody gaming the system so they look better as a leader, so that if the application is used by an organization and they're looking at the results, they go like, oh, this person's leadership material, and getting an opportunity over a next person because they game the system. All those things matter, right? And that's why, again, one of the things I really love about AI is that it is blending, or it is giving more value to people who understand the entire thing, the entire scope, the entire business. Not just a developer who can actually create something for you, but the person who understands product, the person who understands business, the person who understands intellectual property. Because if you're not having conversations on, oh, I need to protect this 24 questions because they're intellectual property. You're not having questions on, oh, somebody can game the system to get favor, and in that case, it's going to reduce, right, the value and the, how should I say this, the not only the value, but the integrity of the assessment, thereby reducing the value of my coach, right? Because now she can go in and go like, no, nobody can game the system. That matters. That translates to dollars, right? That's goodwill, right? That's trust. So that's what AI is. If you're watching this and you say that, Chris, I'm not a developer. I'm saying you don't have to be. You say I'm a business person. I say, great. I come learn this stuff. Come do this stuff, right? Because you're valuable. And now, if anyone's watching who's technical, I'm not saying that you're not valuable too, right? I'm saying that you need to pick up business skills, right? You need to pick up business awareness, because AI puts you so close to the business that if you're not understanding the business, you're not developing to your full potential. All right. So now P9, P10 is now memorialized. Did it memorialize P10? P10. Hey, why did you memorialize P? Oh, sorry. Yeah, it's P10. I was reading wrong. Okay, so let's go to P11, and we're gonna wrap up in the next 15 minutes. End-to-end testing. Yes, another thing that people forget all the time. End-to-end testing. So let's talk about this. But end-to-end testing is a big part of reliability. As a matter of fact, I have a video. Okay, I just got a little email from an active bill. Okay, cool. Yeah, I'm working on an application for a 1,000 truck um 3PL. Pretty big deal. I'm building an operational platform, an AI first operational platform for them. I actually just released it 3 weeks ago, and they're now sending a request in for phase two. Love it. Yeah, this is great. The phase two will actually include integration with Microsoft Power BI and other intelligence platforms. Um, oh, more integration into their DB2, which is their old school mainframe, and they want to open it up to their clients. That is huge, but not a scary thing for me, because when I build AI, I build with scale in mind. So it's a matter of just kind of like latching on a few things. So super cool, really good email to get. But yeah, so let's get back. End-to-end testing is really big for reliability. Why? Because at the end of the day, I'm gonna let you into a little secret. I don't like to do QA. Nobody likes to do QA. How do you get to do less QA? If you build a lot of testing into the process as for agentic coding. So real fact, I just mentioned, again, this is timely. I'm not faking this. I wish I could show you what it is, but I can't, because I don't want to show you the name of the client, because that's confidentiality. But take my word for this. It's really interesting, and apropos that I got this email right now, because it's a good example. It took about 2.5 to 3 months to launch their platform. I don't vibe code. I software compose with agentic AI. So don't get me wrong, a vibe coder could have built this in like maybe 4 to 5 weeks, but it also would have broken in the next 2 to 3 weeks. I agentic compose, right? So it took me about 3 months working closely with the business. It's launched. Now they're exposing it to clients, which is a big deal. So now they're moving from just a transportation company, and they're now saying to their clients, we are a tech leading transportation company. And that's allowing them to actually grow their business, right? This is how important agentic AI has become in a space like transportation. They're now using it as an edge. My client is, right? So just wanted to actually share that. And again, throughout the process, QA hasn't played a huge role, right? Not like in traditional software, or not like in normal vibe coding, because of the process. Excuse me? Oh, give me like a few minutes. I got to rush up with my wife here. But from a reliability engineering standpoint, if I want to create reliable software and I do not want to QA, I need to do more testing. I need to be more specific in my specs. As a matter of fact, there's a simple reliability engineering math here, right? If if a system is made up of, let's say, 10 components, and the system is doing it at a 95% probability that it's going to be done correctly, you do realize that there's only a 60% chance that the outcome is good. 0.95 times 0.95 times 0.95 times 0.95, right? Engineering math, right? Reliability engineering math. That's 60%. Think about this. You can create pieces and go like, man, this is good, because 95% sounds good, but chained together, 0.95 to the 10th power is 60%. Check my math, right? I think it is, right? My point here is that in order to get software outputted from agentic coding, the number one thing that you can do is to ensure that the individual components are as close to 100% as possible. And the way that you do this is by proper process, which is what you see me doing, combing through the ADRs, right? And then being able to use end-to-end testing and unit testing along the way, and putting stage gates so that something doesn't pass the testing until it's ready. And remember, your agentic coding, so that should be automatic. Your harness, your runtime for agentic coding should be such that after I do all of this, I am going to have a graph, a DAG of all the things that need to be created, as well as all the testing for it. And in the DAG, it's going to be written that certain things cannot happen until testing is done and has been 100% approved. And I walk away. I walk away for 20 hours. I walk away for 15 hours. And when I come back, where it is where it is. If it's not 100% and it's at 50%, I know it's at 50% completion, but the 50% that's done, 99%. Right? So end-to-end testing is a real big deal. It says perfect paths can still make a broken whole. This is what I'm talking about. Scripted personas runs for entire assessments. Does a full session actually reach 24 confirm? Correctly within the turn budget. Compounding error is checked at session level, which is what I'm talking about. So that looks good. Cost-aware resilience. Buy exactly as much reliably as the failure would cost. Nothing more. This is an important concept, right? You do not want to over-engineer reliability until it becomes a cost impediment. So you have to align reliability with the cost of if it wasn't there. Sounds fancy, right? So you have to calculate. You say, hey, I'm good here because the stuff that it doesn't catch is going to cost me less than the stuff it could, right? I'm going to make a very, very, very bad analogy, and do not kill me for this. It is the reason why pharmaceutical companies sometimes do not test certain things, because they calculate what the cost of insurance is, of the insurance payment, if it's wrong, right? They go like, hey, we can delay the drug and we can do more testing. It's going to cost us $50 million, or we can let it go through, because if anything bad happens, we'll do a $10 million insurance payout. We're still up $40 million. I know it sounds really bad, but that's the most shocking example I could reach, so you can understand what I'm saying. All right. So again, these here, the rest of these, I'm reading these really fast because I know what they are. And again, I need to kind of jump off here. And I go like, hey, this is good. So I'm gonna say like, I am done with the reliability pillar. From our conversation that we had, I believe all the questions have been answered. Please verify that all questions have been answered and update the required documents. And once we do, that'll be the end of my session here for now. So it's doing its thing. Yep, it says all 3 of your 09 questions have been completed, these were the questions. It's logging my answers in my index and other places. So this is the index. See, all right? It's writing all the stuff into my canon. See that? Which is my core rules. And it's updating my synthesis and ADR backlog, because this is what's going to drive the actual ADR creation, which is the architectural decision records. So very detailed. And it says 9 done. It says 9 out of 8 done. And the biggest one is behind you, which was number 9. So I have like these 8 to be done. And then that will actually finish my review process. So far, these first 9 have maybe taken me like around 4 or 5 hours. As I've said before, this is going to take me like around 10 hours to do. It's something that I do not rush, right? And I continue going strong. From there, I will actually then create what's called story arcs, right? Where I kind of break down what I have to do in little like boundaries. And then after I do the story arcs, then I actually write the PRDs, which is the product requirement documents. And then I also write specification files. And then from that, I then start creating like my smaller stories. And once I create my stories, then I write my test plans. And once I run my test plans, I then create my DAG. And once I create my DAG, I can then say, hey, Claude Code, go ahead and code this. And I walk away. So I should be into coding by this weekend. I know it sounds long. I don't vibe code. I don't YOLO. I software compose, because I build things for real companies with real consequence. Thanks for joining. I'll see you later.